students. So this is mathematics class. So here already we have discussed some part of continuity and differentiability. So in differentiability, the composition of derivative of composition function is over. So this is the second concept of derivative, that is derivative of implicit function. So first let me know what is the implicit function. So I can take some of the relations like x minus y minus 5 is equal to 0. This is one relation. In again x plus sine of x into y minus y square is equal to 0. So these are two relations. Students, see that these two relations. So this is say the relation 1. Say this is a relation 2. So what we have to do that? So in relation 1, in relation 1, we can easily solve for y. This equation we can easily solve for y. We can easily solve for y. And this equation is rewritten as rewrite as that is y is equal to x minus 5. So the result of form y equal to f of x form. Clear that? So here the relation 1 can be easily solved for y. That is, we can rewrite this equation as y is equal to x minus 5. So that is the form y equal to f of x. So in this form of examples already we solved. For example, we can take examples. For example, y equal to x square plus 2x. This one function. So derivative of this function is dy by dx is equal to 2x plus derivative of x square is 2x. Derivative of 2 into x is take 2 common. Derivative of x is 1. So this is derivative of explicit function. So this type of functions are called, what is that? Explicit function. Whereas in second case, what is second case? X plus sine of x into y minus y square is equal to 0. Okay. So here in this equation we cannot easily solve for y. In this equation we cannot easily solve for y, and we cannot rewrite y is equal to f of x form. We cannot rewrite y equal to f of x form. Okay, so this type of relations are called implicit functions. So what is that? So in first relation we can easily solve for y and rewrite as y equal to f of x form. Whereas in second case we cannot easily solve for y, or we cannot rewrite the equation as the form y is equal to f of x. Okay, so here this is one example. Then what we can the definition of this function should be, so the relation between x and y can be expressed in terms relation between x and y can be expressed in such a way that it is easily solved for y and rewrite as y equal to f of x form. Here y is said to be explicit function of x. So what is the definition of this one? So very simple definition, that is x and y are the relations between x and y are expressed in such a way that we can easily solve for y, and this relation should be rewritten as y equal to f of x form. So here y is said to be, what is that? Explicit function of x. Is clear that? Otherwise that is said to be implicit function. So what is the implicit function? The relation between x and y, cannot be rewritten in the form of y is equal to f of x. In that case, the y is said to be implicit function of x. Is clear that? So for example, so this is implicit function. So x square plus 2x. This is explicit function. So in first PUC and in previous class we can studied about the explicit function. Is clear that? So in this class we study implicit function. Okay. So make note this. Then next, how to solve implicit function, derivative of implicit function. This is very important. Okay, I can take example. Same as find the derivative of find dy by dx if x minus y is equal to 5. This is very simple example. Okay, I can solve as a implicit function as well as explicit function, because this relation can be rewritten as y equal to f of x bar. Okay, first let us consider, let x minus y is equal to 5 or y is equal to, this can be written as x minus 7. Okay, then differentiate this function, we get derivative of y. So dy by dx is equal to, derivative of x is 1, so derivative of y should be 0. The answer should be dy by dx is equal to 1. This is your final answer. So this is the for explicit function. So I can take. Or alternatively, what is the implicit function method? Implicit function method. That is x minus y is equal to 5. So in this relation, we directly apply the derivative. When implicit function should be derivative, then we directly apply the derivative to both sides. Okay? So apply derivative on both sides. Apply derivative on both sides. Apply derivative on both sides is nothing but d by dx of x minus y is equal to d by dx of 5. Okay, so here d by dx of x separately minus d by dx of y separately, then d by dx of 5 is a constant function, then derivative of constant function is 0. Okay, then again the derivative of x should be 1, d by dx of x. So this is with respect to x, this function should be x. So d by dx of x should be 1. But in second case, this is d by dx of y. So derivative of y with respect to x it is. So when we differentiate y, then we write dy by dx. Here there is no function, so d by dx of y. So d by dx of is equal to 0. Okay, then simplification will get dy by dx is equal to 1. dy by dx is equal to 1. So in both method the answer should be dy by dx equal to 1, dy by dx equal to 1. So this is our very easy method. What is that? This is explicit method function. So this is implicit method, solving for implicit method. Is clear that? But every example cannot be solved for explicit as well as implicit method. This is very easy relation. That's why we solve both the method. Okay, then next we can take another example. So you have that idea. Okay, write down this one. I can take another example. This is 2 marks concept, students, very important. 2 marks, 1 fixed question is coming in your annual examination. Okay, next example you can take find dy by dx if y plus sin y is equal to cos x. Y plus sin y is equal to cos x. So in this relation we cannot rewritten as y equal to f of x form. So this is purely implicit function. It's clear that? So then we apply the derivative of implicit function. Is clear? So first of all, we can take y plus sin y is equal to cos x. Okay, here LHS had y plus sin y and RHS had cos x is there. So directly apply the derivative. Apply derivative on both sides with respect to x. With respect to x, we get. So derivative of with respect to x. This is very important. Is clear that? So first one, d by dx of y plus sin y is equal to d by dx of cos x. D by dx of cos x. Okay. So here, so this is d by dx of y plus sin y. So I can solve step by step, or else directly we can derivative in next example. But in this example, I can solve step by step. So here, d by dx of y plus d by dx of sin y. D by dx of sin y. And again we can write d by dx of cos x. So students, this is d by dx of y. Here there is no function, so keep as it is d by dx of y. So derivative of y should be dy by dx. Keep as it is. That is dy by dx plus here. See that d by dx of sin y is there. So this function is, so this is derivative of x is there, but this is the function in terms of y. So then what we can apply that here, derivative of sin x. First of all, what is the derivative of sin x? Derivative of sin x is cos x. So likewise, already we know that the composition of a derivative method. So apply that method, or else directly we can write the derivative of sin y with respect to x is there. So what we can do that? So keep derivative of sin y, instead of x we can replace as y. That is derivative of sin y is cos y. When we differentiate the function in terms of y, then we compulsory rewrite it as dy by dx. This is very important. Is equal to. Friends, this step is very important for you people. When we differentiate the function of y as x, when we differentiate the function of y as x, then we can write as dy by dx. Is clear that? So derivative of sin y is, now already we know that the formula for derivative of sin x is cos x, but here function is sin y. So derivative of sin y is cos y. When we differentiate the function of y, then we can write multiplication term as a dy by dx. Is it clear that? So here there is no problem. D by dx of cos x. Here x is there. Here also x is there. So derivative of x. So derivative of cos x is minus sin x. Derivative of cos x is minus sin x. Okay. Then what we have to find that? Dy by dx. So here take dy by dx term common. Dy by dx term common. Remaining term is 1 plus cos y is equal to minus sin x. Is equal to minus sin x. Then the next step is dy by dx is equal to cross multiplication you get. So already minus sin x is there. Minus sin x whole divided by, what is the term? 1 plus cos y. 1 plus cos y. Friend, this is the method. Okay, we can solve implicit function. So here we can directly write the derivative of y is dy by dx. The derivative of sin y is cos y with respect to dy by dx. When we differentiate the function y, then we compulsory multiply the term dy by dx. This is very important. It's clear there? So not only this example, this is also very important example, friends. Very important example, friends. Then next based on the implicit function examples are discussed in your exercise. Okay. First, write down this example. So students, the next concept is, that is derivative of inverse trigonometric function. Derivative of inverse trigonometric function. This is also important concept for 2 marks. Important concept for 2 marks. So already we know that inverse trigonometric functions. Already we know that inverse trigonometric function. There are 6 standard inverse trigonometric functions are there. So already we studied in the chapter, that is inverse trigonometric function. So here then we studied the derivative of inverse trigonometric function. So first of all we differentiate some of the standard function like standard inverse trigonometric functions. So first we know the standard derivative of standard inverse trigonometric function. Okay. So first I can take f of x equal to sin inverse of x. So what is that? Find the derivative of f given by f of x is equal to sine inverse of x. Assume it is exists. Assume that it exists. Okay. So first of all, by using the implicit function, we can solve for derivative of inverse trigonometric function. By using implicit function, we solve inverse trigonometric function, derivative of inverse trigonometric function. Okay. First, let us take f of x or else y is equal to sine inverse of x. Y is equal to sine inverse of x. Y equal to sine inverse of x, and next I can write y equal to sine inverse of x. Sine inverse of x. So already we know that we shifted to sine inverse function to left hand side, it will become standard trigonometric function. So that is x is equal to sine. So x keep as it is. So sine inverse function shifted to that side, it will become standard function, that is sine y. Is clear that? So this is implicit function. So then differentiate we get. So differentiate we get. So derivative of x. So I can directly apply the derivative, or else one step d by dx of x is equal to d by dx of sine y. D by dx of sine y. Okay. So already we know that. So d by dx of x. So derivative of x with respect to x is 1. Okay. So d by dx of sine y is there. So already I told that. So this is of the function in terms of y. So derivative of sine y should be written as derivative of sine y is cos y with respect to dy by dx. What is that? D by dx of, so derivative of sine y with respect to x is there. So first what we come to that? So this is of the form sin x. So derivative of sin x, already we know that cos x. So that's the way. So derivative of sin y is cos y. When we differentiating the function in terms of y, then we compulsory write dy by dx as a multiplication term. This is very important. So derivative of sin y is cos y into dy by dx. When we differentiating the function of y, then we compulsory write dy by dx as a multiplication term. Is clear that? Then dy by dx equal to 1 divided by cos y. 1 divided by cos y. Dy by dx equal to 1 divided by cos y. So then dy by dx is equal to 1 divided by cos y can be written as root of 1 minus sin square. Root of 1 minus sin square by 5. So already we know that. Sin square y plus cos square y equal to 1. This is one standard trigonometric relation. Okay. Then what is cos square y? Cos square y equal to 1 minus sin square y. 1 minus sin square y, or else what we have to do that? Cos y equal to under root of 1 minus sin square. Under root of 1 minus sin square. Is clear that? So the cos y can be written as root of 1 minus sin square 1. Is clear that? Then dy by dx is equal to 1 divided by, so root of 1 minus, so sin y is said to be, what is that here? Sin y is x. What is the value of sin y? What is the sin y? X. The value of sin square y should be x square. So this is d by dx of sin inverse of x. D by dx of sin inverse of x equal to 1 divided by root of 1 minus x square is the standard formula. This is one standard formula. It's clear? That is simple. What we can do? Take y equal to sin inverse of x or x equal to sin y. Differentiate, we get d by dx of x is equal to d by dx of sin y. Derivative of x, already we know that 1 is equal to derivative of sin y is cos y with respect to dy by dx. When we differentiating the function in terms of y, then we multiply the term dy by dx. Okay, then dy by dx is equal to 1 divided by cos y. So cos y is this is a trigonometric function by using relation. So cos y should be written as root of 1 minus sin square y. Root of 1 minus sin square y. So already we know that the value of sin y, the value of sin y is x. That's why the sin square should be 1 minus x square. So this is the y should be, what is your y? Y is your sin inverse of x. So that is d by dx of sin inverse of x is equal to 1 divided by root of 1 minus x square. Clear that? So students, this is very important standard formula. So like that same, we can also find that f of x is equal to cos inverse of x. F of x is equal to cos inverse of x in the same way. Is clear that? So you can write this one. The next I can solve another inverse trigonometric function. Okay. Students, the next inverse trigonometric function is find the derivative of f given by f of x equal to cot inverse of x. F of x equal to cot inverse of x. This example can be solved by using same previous method. So first let us take function f of x is equal to f of x should be taken as y is equal to cot inverse of x. Cot inverse of x or y equal to cot inverse of x. So already we know that. Then the cot inverse function shifted to left hand side, it will become standard trigonometric function. That is, this step will imply that x equal to cot y. X equal to cot y. So this is implicit function. Then apply derivative on both sides. Apply derivative. Apply derivative again. Derivative of x should be 1. Directly I can write, or else take another step. D by dx of x, d by dx of cot y. So d by dx of x should be 1. And do we know that? So what is the derivative of? This is d by dx of y. So derivative of this is d by dx of y. Here there is no function of x. So same way we can use. This can be treated as cot of x. What is the derivative of cot x? Minus cos x square x. Is clear that? Minus cos x square x. So then derivative of cot y is minus cos x square y. So minus cos x square y with respect to dy by dx. When we differentiating the term in terms of y, then we can write dy by dx. Derivative of cot y is minus cos x square y with respect to y is dy by dx. Is clear that? Okay. Then what is dy by dx? Dy by dx equal to minus 1 divided by cos x square y. Minus 1 divided by cos x square y. So already we know that the formula dy by dx is equal to minus 1 keep as it is. So cos x square y can be written as 1 plus cot square. 1 plus cot square. Is clear that? So already we know the relation. What's the relation? 1 plus cot square y equal to cos x square y. This is the standard relation. So that means the cos x square y can be written as 1 plus cot square y. Okay? Then this is d by dx of y should be cot inverse of x is equal to minus 1 divided by 1 plus what is the cot y? So if this is cot square y, the value of cot y is x, then cot square y is x square. So this is also standard formula. Is clear that? So I can solve as a negative term. So in previous example sin x, I can solve as a positive term. Then you people solve cos inverse of x. So that answer should be in terms of negative. Is clear that? Then tan should be positive, cot should be negative. Okay? Write on this example. So students, this is also find the derivative of f given by f of x equal to sec inverse x. Assume that it exists. So this example can be solved by using previous method. Okay. First of all, let us take what is that? F of x is equal to sec f of x equal to y, that is equal to sec inverse of x, or y equal to sec inverse of x. So the inverse trigonometric function shifted to left side, it will become x equal to sec y. X equal to sec y. Then apply the derivative. This is implicit function. Apply derivative. Apply derivative. We get, what is the derivative of x? Directly I can write derivative of x is 1. Derivative of x is, or I can write the d by dx of x, d by dx of sec y. Okay, derivative of x should be 1, already know that. So derivative of sec y. So here derivative of y with respect to x is there. So here d by dx of sec x. Already we know the formula called d by dx of sec x. But here d by dx of sec y is there. So treated this sec y as a sec x and differentiate. Okay, already we know that. So here derivative of sec x is sec x into tan x. Derivative of sec y is sec y into tan y with respect to dy by dx. Because we differentiate the function in terms of y, then we can write dy by dx as a multiplication term. Okay. So here derivative of sec y is sec y into tan y into dy by dx. This is standard formula. Derivative of sec y is sec y into tan y. When we differentiate the function of y, then we can write dy by dx. Okay. Then dy by dx equal to, simple as that, dy by dx is equal to 1 divided by sec y into tan y. 1 divided by sec y into tan y. Okay. The next, dy by dx equal to 1 divided by sec y, keep as it is. So tan y can be written as tan y can be sec y, keep as it is. The what is the relation? So already we know that the relation tan y can be written as tan square y equal to sec square y minus 1. So tan y equal to root of sec square minus 1. Okay, so same. So sec y keep as it is because the value of sec y already we know that x. So tan y function can be written as tan y equal to root of sec square y minus 1. Root of sec square y minus 1. Okay. And the last step, d by dx of y should be, what is that? Sec inverse of x. Sec inverse of x is equal to 1 divided by sec y. Sec y is x into under root of sec square y minus 1. Sec square y is, that is also x square minus 1. So this is the formula. Is clear there? So this is can solve this method. Okay. Derivative of, so already we solved this, that derivative of sin inverse of x, derivative of cot inverse of x, derivative of sec inverse of x. And your work is f of x equal to cos inverse of x, f of x equal to tan inverse of x, f of x is equal to, what is that? Another one is cosec inverse of x. Cosec inverse of x. These are your works. Okay? Same method as sin inverse of x, this is cos inverse of x. Same method as cot inverse of x as tan inverse of x. Same method as sec inverse of x is cosec inverse of x. So this is all about what is that? Derivative of inverse trigonometric function theory as well as some standard problems. And in next class I will discuss the exercise based on derivative of implicit function as well as the derivative of inverse trigonometric function. Okay, so here this session is over. Okay, thank you.